Now, I want to talk about these things called surds. Surds are just when you have, we call it a radical symbol. For example, if I took the square root of 2, the root symbol is called a radical symbol. So square root of 2 is called a surd. It doesn't just have to be square root, you know. I could also take the cube root as well. That's also a surd. For now, I'm just going to deal with these particular ones, square root of 2. And I'm going to apply some particular principles that we can use to do things with surds. By the way, that's a really, really useful format, because if you do some calculations and it comes down where you've got to take the square root of 2, as we saw in the last video, if you plug that into your calculator, you get this big, long, horrible, ugly, messy decimal. It doesn't repeat, it doesn't end. So no matter what you write down, you're writing it down in a slightly inaccurate form, and the more decimal places you write, pardon me, the more decimal places you write, well, the more accurate it becomes, but it's still not accurate. It just becomes messier and uglier the more you write down. Writing down the square root of 2 is the most accurate way you can write it down, and it's the simplest way you can write it down. So we're going to have a lot of practice at being able to use these over time. Now, first of all, a couple of things that we need to know about surds and square roots and so on is a principle like this. If I've got one particular number multiplied by another, square root of one number multiplied by another number, I'm actually able to combine them together under the square root symbol. Square root of a times square root of b is equal to square root of a times b. For example, if I did square root of 2 multiplied by square root of 12, I end up with the square root of 24. So that's one principle. It works in reverse. If I've got two numbers times together underneath a square root symbol, I can split them out like that to become multiply. For example, if I take the one that I've got here, I could split it back to be square root of 2 times square root of 12. I'm actually going to split it back to become another pair of factors of 24. I'm going to split it to become square root of 4 multiplied by the square root of 6. Because if I now apply this principle of working backwards, I can split the square root over the 4, I can split the square root over the 6, and I'm kind of hoping you would look at that and go, hey, square root of 4 is 2, I can't do anything with the square root of 6, voila. So if I'm to do, you'll get questions like this where you might say, simplify root 2 multiplied by root 12. So what are you required to do? Step 1, combine them under the same root symbol. Step 2, split them like this, so that you can take the square root of a nice easy one, and then whatever's left over. First question is, well, how do I know what to split this in to do something easy down here? You'll always be looking for this pattern. See if you can split a number into factors where one of the factors is a square number. The square numbers are, one's a square number, but we'll never use that because it's a simple case. Square after 1, the square numbers are 4, 9, 16, 25, 36, etc. So when you ask to simplify a surd, if you can find a factor of that that is one of these particular square numbers, in this case 4 is a factor of it, split it like this, take the square root of them individually, and simplify it down. So if you were to get your calculator out and go square root of 2 multiplied by square root of 12, you'll get a certain answer. If you then go the square root of 24 on your calculator, you'll get exactly the same answer. And if you go 2 multiplied by the square root of 6, you'll get exactly the same answer again. This line, and this line are all exactly the same value. It's called simplifying. This is a much more simple version to use than this or this. And that's what we're doing at the moment. We're going to simplify surds through this multiplying and dividing process. Divide works for us just as well. Now, if I had a question like this, I was asked to simplify, the same pattern applies. Whatever you can do for multiply, you can do for divide. So I'm actually allowed to put the 1 square root symbol down and just put 14 divided by 7 in there. 14 divided by 7 is 2. So square root of 14 divided by square root of 7 simplifies down to the square root of 2. And we can't take that any more simple. You might want to get your calculator out, type this in, get an answer, type this in, simplifying it, you get exactly the same answer. Alright, let's put it all together into a bigger problem. You're asked to simplify this. No use of calculators. So let's see what we do. The first thing you need to notice is you've got some normal easy numbers here. You've got 12 on the top, 3 on the bottom. That's easy to do. I can do 12 divided by 3 to get an answer of 4. So that part's straightforward. I've now got root 40 divided by root 5. I know that I'm allowed to put the 40 and the 5 together under the root symbol. So that's going to simplify down now to 4 multiplied by square root of 8. There's the first level of simplification. Combine the easy numbers at the front, 12 divided by 3 to give 4. If there had been some multiplies there, you could have done them as well. Then secondly, combine the roots together under the one symbol and get square root of 8. Next step is we can simplify this further. So remember, when we come to simplify them, can I split 8 into two numbers multiplied together where one of those numbers is a square number? And yes, I can. I know that 8 it factorizes into 4 multiplied by 2 where 4 is a square number. I'm now allowed to split the square root symbol over the 4 and I'm able to split it over the 2. End result is I have that 4 at the front still. Square root of 4 I know is 2. Square root of 2 I can't do anything with. I can now write down my final answer, which is going to be 4 times 2 is 8 times square root of 2. So the question says simplify this, that simplifies down to that. If you want to do that on your calculator and get an answer, do that on your calculator and get an answer, you'll see they are exactly the same value. And this is clearly much more simple than that is. Now, just one thing I want to point out, a mistake that a lot of people make. If I've got the square root of, let's say, 2 multiplied by the square root of 10, that gives me the square root of 2 times 10, which is square root of 20. That is the rule that we work with. You cannot do this. If I had the square root of 2 plus the square root of 10, you cannot, under any circumstances, ever do square root of 2 plus 10. It just doesn't work. Check to make sure, plug that into your calculator, plug that in, see they're the same. Then, plug that into your calculator and plug that in and see that they're not the same. Adding surds, well, that's what I'm going to go on to in the next video. And I'll talk with you more about that then. Oh, by the way, this deals with exercise 12.2.